Welcome to the Deep Dive, your shortcut to being the most informed person in the room. Today, we're diving into, well, what it really takes for AI success. It's not just about brilliant algorithms, is it? You need both this surgical operational rigor and some pretty deep strategic foresight.
That's exactly right. Our mission today is built on two, complementary sets of sources that really get to the heart of this challenge.
Okay.
We've got this detailed 7-phase blueprint for building a single AI model ethically, reliably. That's the technical how.
Right.
And then we've got a high-level strategic playbook. This is more for the executive leaders, focusing on the when and why of navigating these, explosive AI waves we're seeing.
So we're connecting the micro and the macro here. Going from the real nitty-gritty technical stuff, data governance, security, compliance,
Right.
things like dealing with the EU AI Act, all the way up to those big business decisions. Which wave do you ride? Where do you put your money?
And you absolutely need that dual vision for success in this space. I mean, without the operational rigor, your models could fail, or worse, introduce serious ethical risks.
Yeah, dangerous.
But without the strategic foresight, you might end up optimizing the perfect product, but at totally the wrong time, or for the wrong market.
So we're here to help you connect those two dots.
Precisely.
Get ready then to absorb this comprehensive 7-phase life cycle for model trustworthiness and also a structured guide for adopting AI across your organization.
Okay, let's unpack this. Where do we start? Right at the beginning.
Let's start right at phase 1 of the model life cycle.
Okay, so when most people think AI development, their mind jumps straight to the training part, the coding, the big servers.
This exciting stuff.
Yeah. But the sources we looked at, they make it crystal clear. Trustworthiness, security, ethics. These are foundational. They're not features you just, bolt on at the end.
Absolutely not. They have to be baked in from phase 1.
This 7-phase life cycle approach, it really provides a critical framework for everyone involved, really, from the junior dev right up to the CEO.
Okay.
It basically forces the team to nail down those safety and ethical parameters before they even start collecting data or writing a single line of code.
And if you skip phase 1?
Well, you're essentially embedding risk into the project before it even gets off the ground. It's a recipe for problems later.
Phase 1 then, it's called planning and conception. The sources really hammer home that this careful groundwork is the only way to guarantee the model does what it's supposed to do and, crucially, operates safely.
Exactly. It starts with defining the purpose.
Okay, the purpose.
What specific, measurable task should this model achieve? Is it, say, predictive? Is it meant to be conversational?
Right.
If it is conversational, what's the scope? Customer service chatbot?
Yeah.
Or something handling, sensitive financial advice. Big difference.
Huge difference.
Yeah.
And the target audience, too, right? Who exactly is using this?
Precisely. The end user dictates the safety parameters, the accuracy needed. I mean, a model just for internal data classification. Totally different risk profile than a public-facing model that could impact consumer safety or finances.
So, to make this less abstract, the sources give us a great example, the recipe generator.
Oh yes, the recipe generator.
The goal seems simple, help users create recipes. But the requirement, and this is key for phase 1 safety, is super specific. The model must be engineered right from the start to actively avoid giving unsafe or just plain wrong recommendations.
Think about that safety requirement. Preventing a user from getting a recipe that says, put glue instead of cheese in their lasagna.
Yeah, seems obvious.
It seems obvious, but actually achieving that reliably. It requires fixing that ethical commitment right up front. If the model's purpose is instruction, its core ethical requirement is basically do no harm, non-maleficence, prevent physical or financial harm.
Okay.
And the sources stress this ethical alignment, this commitment to trustworthiness. It has to be finalized before you even think about moving to data collection.
Why is that timing so critical?
Because those ethical guardrails you just set up, they determine the data rules for the next phase.
Ah, I see. So if the model can't suggest dangerous ingredients,
Then you immediately know you can't train it on random, unverified ingredient lists scraped from dodgy corners of the internet.
right. That decision in phase 1 dictates the quality and vetting needed for phase 2 data.
Exactly. It all connects.
Okay, here's where, as they say, the rubber meets the road. Because the sources just keep reminding us, good AI starts with good data, period.
It's the mantra. This foundation phase is absolutely critical for the model's reliability, its fairness, and, its long-term compliance.
So building on that ethical commitment from phase one.
Right. The data selection has to align perfectly with that defined use case.
Yeah.
So our recipe generator, it doesn't just need heaps of random text.
No.
It needs high-quality conversational data. It needs specific recipes, but only from reputable, vetted sources. And it needs verified sound cooking techniques, not just anything goes.
And the sources outline a couple of key requirements for every bit of data you collect, right? Diversity and traceability.
Yes, crucial attributes. First, diversity. The data needs to reflect diverse backgrounds, perspectives, whatever's relevant to the use case. If your recipe generator only knows about French cuisine,
Yeah.
but you market it globally, it fails the diversity test. Simple as that.
And the second one, traceability. Why is that so important, especially for compliance?
Oh, it's critical. Traceability means every single data unit, every recipe snippet, every technique description must be traceable back to its original source.
Okay.
If you can't verify the source, you simply cannot guarantee its quality. You can't ensure compliance, say with copyright, or even the ethical background of that data. Was it sourced responsibly? You need to know.
Got it. And once you've gathered this raw data, then comes the cleanup crew.
Exactly. The rigorous process of data cleansing begins. And this is way more involved than just running a spell check.
I bet. What's involved?
Crucial steps, like removing PII, personally identifiable information. That's a massive headache under laws like GDPR.
Right.
If you accidentally train a model on someone's name, address, phone number, you've got a compliance nightmare on your hands.
Okay, so let's pause on PII. For the recipe generator, maybe it scrapes comments and finds usernames, maybe location data. What's the actual risk if that PII isn't scrubbed out?
The risk is enormous. I mean, beyond the immediate legal fines, which can be huge.
Yeah.
If the model trains on that PII, it can actually memorize it and then inadvertently regurgitate it later.
Wow.
So your recipe generator could potentially leak one user's private info to another user just because they happen to ask the right kind of question or prompt.
Yeah.
It completely shatters trust and security.
Okay, so that cleansing step is absolutely non-negotiable. It's non-negotiable. You also have to deduplicate data sets. You don't want the same bad recipe repeated 1,000 times, skewing the model.
Wow.
You need strategies for replacing or logically handling missing values, and you have to standardize all the formats so the machine can actually read it consistently. And even after all that cleaning, you're still not done with the data checks.
Not quite. After cleansing, you have to actively check for biases. Is the data unfairly skewed? Is representation unbalanced?
Okay. Like if certain cuisines or dietary needs are underrepresented.
Exactly. If you find, say, certain demographic groups are underrepresented in the cuisine data, or maybe the language input is heavily weighted towards one particular region, you have to intervene. You can't just let it go.
And how do you intervene? What if you just don't have enough real-world data for certain groups?
That's where a specific technique mentioned comes in, generating synthetic data.
Synthetic data. Okay, explain that.
It's data that's artificially created, but it's designed to be statistically representative of the real data you're missing. It's a really critical tool to fill those gaps when certain groups or conditions are underrepresented in your collected data.
Ah, I see.
It helps ensure the model gets a more balanced, fair view of the world it's supposed to understand. Super important for our recipe generator if it needs to cater fairly to, say, different cultural dietary needs or allergies.
So you're actively engineering fairness into the foundation.
That's the goal. It's proactive.
Yeah.
Okay, so we've set the rules, we've prepared the raw materials, the data. Now we move into the actual technical build and, importantly, the validation phases.
Right. Phase 3, development and architecture. So for our recipe generator, needs to be conversational, needs to follow instructions. What kind of engine are we looking at?
Well, given its need for processing and generating complex text, a transformer architecture makes a lot of sense. That's the bedrock of most modern large language models, the LLMs you hear so much about. Okay, standard stuff. But the sources mention something about optimization here.
Yeah.
Even at this technical level, leaders need to think about efficiency.
Absolutely. They introduced this idea, an optimization nugget, they called it. The mixture of experts, or MOE architecture.
MOE. I've heard that term. A lot of people might just assume it's like a bigger model made of smaller ones, an ensemble. But it's smarter than that, right?
It's fundamentally different, and yeah, strategically much smarter, especially for cost control. See, a traditional large language model, it activates all its billions of parameters for every single query. Hugely expensive computationally.
Right. Burns a lot of energy.
Exactly. The MOE architecture, though, it has several smaller, specialized models. These are the experts. And for any given task, it only activates a sparse subset of those experts, the ones most relevant.
Ah, okay. So not the whole thing every time.
No. It dramatically improves performance, speed, and it simultaneously slashes those massive computational costs and the environmental impact, too, that comes with running these giant models. It's a real efficiency multiplier. That's a really important distinction for anyone managing budgets or resources.
Okay, so you've chosen your architecture, being optimized with MOE. Then we hit phase 4, evaluation and validation. This sounds like the big compliance checkpoint.
It absolutely is. And this phase demands real institutional rigor. The sources strongly recommend establishing an independent AI governance review board.
An internal watchdog group.
Essentially, yes. This board is critical. Their job is to ensure the model strictly adheres to all the internal policies set out in Phase 1 and meets all external regulatory requirements. They specifically mention compliance with the tough demands expected for high-risk models under the EU AI Act.
So real teeth. And the testing itself, how rigorous does it need to be?
Extremely rigorous. You must measure performance not just overall, but across different demographic groups. You're actively hunting for any embedded bias that slipped through the data phase.
And how do you find those hidden problems, the unknown unknowns? You have to systematically brainstorm and test specific edge cases. These are the weird, rare, or unexpected scenarios designed to push the model right to its limits, to see where it breaks or acts unpredictably.
Okay, give me an edge case for the recipe generator.
All right, how about this? What if a user asks for a peanut-free dish, but then somewhere else in the same rambling prompt, they use the word nut in a completely unrelated metaphor like, that's nuts.
Ah, tricky.
Very tricky. The model has to understand the context, prioritize the critical safety requirement, peanut-free, over the metaphorical use. It needs sophisticated handling of nuance.
And what if you do find problems during this testing? Disparities in how it treats different groups or safety failures on edge
Next
cases?
stop, adjustments must be made immediately. This could involve tuning the algorithm itself, or very often going back to the data-targeted data augmentation, often using that synthetic data again to specifically address the weakness you found.
So it's an iterative loop back if needed.
Absolutely, you don't proceed until the governance board is satisfied.
Okay, governance board signs off. Model is validated, safe, accurate. Now we move to phase 5, deployment, getting it out there.
Right. And the key here is that deployment must be repeatable, it must be automated as much as possible, and it absolutely must be secure.
What does that look like technically?
You need a robust technical architecture, usually involves using a reliable cloud platform, setting up automated systems for storage, compute resources, networking, and a really key technical piece for ensuring consistency is containerization.
Containerization, can you break that down? Why is that so critical for deployment?
Sure. Think of a container like a standardized shipping box. Containerization packages the AI model and all its necessary dependencies, specific libraries, the runtime environment, operating system settings, everything it needs to run into a single, secure, isolated unit, the container.
Okay.
This guarantees that the model operates identically, whether it's running on a developer's laptop for testing, on a staging server, or in the main cloud production environment where users access it.
So it prevents the, well, it worked on my machine problem.
Exactly. Without containerization, you run this huge risk of tiny differences in environments. A slightly different library version, maybe causing the model to fail or behave weirdly in production, even if it passed all the tests. It ensures consistency and reliability, which is paramount.
No, it's really vital to remember, and the sources emphasize this. The lifecycle doesn't just stop once the model is live. Deployment isn't the finish line.
Not at all. The sources treat a deployed model like a living asset. It needs continuous care, continuous operational attention to stay trustworthy.
Which brings us to phase 6, monitoring and maintenance.
Precisely. Continuous monitoring, proper version control for the model and its data, and having planned retraining pipelines. These are all essential to keep the model healthy and performing as expected in the real world.
And if you stop monitoring...
Your investment is basically wasted within months. The model will degrade.
Okay, so the biggest threat once it's live is something called drift. Can you explain what drift looks like? Maybe for our recipe generator.
Sure. Drift happens when the model's performance starts to change over time, so it no longer delivers the results that were validated back in phase 4. There are two main kinds.
Okay.
First, there's data drift. This happens when the input data the model sees in the real world starts to change. Maybe users begin asking for recipes using new slang or asking about new trendy ingredients the model hasn't seen before. The input patterns shift.
Got it. And the second type?
That's concept drift. This is more subtle. It's when the underlying relationship the model learned changes in the real world. For example, maybe a major new dietary study comes out, and the public perception of what constitutes a healthy recipe shifts significantly. The model's old definition of healthy becomes outdated. The concept itself has drifted.
Ah, okay. So continuous monitoring has to watch for both kinds of drift and also for bias creeping back in over time.
Exactly. You need to track key metrics. Some are technical performance metrics like throughput, how many requests can it handle, latency, how fast is it, overall error rates.
Standard stuff.
But crucially, for trustworthiness, you must track safety and fairness metrics. Things like the frequency of safety guardrail failures. How often does it suggest something unsafe? Or toxicity output, is it generating harmful language? For our recipe generator, the system must have automated alerts. If that rate of unsafe recommendations starts to tick upwards, even slightly, alarms need to go off.
And what do you do when the alarms go off?
You need an explicit retraining plan ready to go. This involves having automated alerts linked to pipelines set up for periodic refreshing or full retraining of the model, using new, validated data that reflects the current reality. It's proactive maintenance.
Okay, makes sense. And finally, phase 7, retirement. Even models get old. Do they just disappear?
No, the sources say you need a formal plan even for decommissioning. Retirement isn't just hitting delete.
What does that involve?
It involves properly archiving the entire historical project. That means the final model, yes, but also the data it was trained on, the code, all the validation reports from the governance board, the monitoring logs,
Yeah.
everything.
Why keep all that for a retired model?
Two main reasons. One, for potential future auditing. Regulators might come knocking years later. Two, that massive investment in development and training isn't totally lost. That archive can potentially serve as a valuable starting point, a basis for jump-starting future related AI development cycles. It effectively closes the loop on the model's journey, ensuring value is retained. All right, so we've really dug into the operational rigor needed for building one trustworthy model. Now let's pivot. We need to zoom out to the executive view.
Okay, shifting gears.
Yeah, the challenge here changes quite a bit. It's less about the technical safety of a single model and more about strategic timing, resource management, and understanding the broader landscape. You can use the concept of technological waves, of these big disruptive cycles, often attributed to the economist Joseph Schumpeter as a framework here.
Technological waves, like Kondrativ waves.
Similar idea, yes. Schumpeter argued major innovations hit the economy in these long cycles, causing disruption and then new growth. We're arguably navigating the sixth wave of innovation right now, and it's centered on AI. And crucially, it's moving incredibly fast. Hashtag 2.1, understanding the current sixth AI wave.
Yeah.
But here's the key thing for leaders. This current AI wave, it isn't monolithic. It's not just one thing. It's actually a series of really rapid surges or subwaves that you have to understand.
Okay, so it's not just AI. What are the main components or surges the sources identify within this sixth wave?
They break it down into roughly 4 stages, kind of building on each other. First, you've got the baseline, descriptive AI.
Descriptive AI.
Yeah, these are the systems that analyze vast data sets to recognize patterns, show trends, think traditional business intelligence, historical data analysis, foundational stuff.
Got it. What's next?
Next comes the surge that's really dominant right now, generative AI, or Gen AI. This is where large language models, the LLMs, fit in. Content generation, natural language interaction.
Right, the stuff everyone's talking about. Now, within Gen AI, the sources specifically called out RAG models, retrieval augmented generation. Sounds pretty technical for a strategic leader. Why is ARG important from their perspective?
It sounds technical, but its strategic value is actually quite simple and solves a huge corporate problem with basic LLMs, hallucination, or making stuff up.
Oh, okay, big problem.
Huge. A standard LLM. It's limited to the knowledge baked into its massive but potentially outdated or generic training data. RAG system, however, is different. It augments the LLM. Before generating an answer, it first retrieves relevant information from a specific, secure, often proprietary knowledge base, like a company's internal documents, manuals, databases.
I see. So it grounds the response in trusted information first.
Exactly. It uses that verified retrieved data to formulate the response. Strategically, this is massive. It means Gen AI can be safely grounded in your company's own up-to-date information. This instantly creates real business value for internal tasks and dramatically reduces the risk of the AI giving inaccurate answers or leaking confidential training data.
So RG essentially makes Gen AI a reliable tool for serious corporate use cases, not just, writing poems or summarizing articles.
Precisely. It bridges the gap to enterprise reliability.
Mm.
But things are moving fast. Following rapidly behind Gen AI is the next potential major surge, agentic AI.
Agentic AI. Okay, what does that mean?
These are systems that don't just generate content or answer questions. They can actually execute tasks autonomously. They can make decisions, take actions in digital or even physical environments, and importantly, learn from the outcomes of those actions without constant human hand-holding.
Whoa. Okay, that sounds like a profound leap.
It really is a step-changing capability.
But that immediately brings up a critical point, connecting back to our first section. If a system is autonomously executing tasks, ordering things, changing configurations, managing processes, the risk profile must shoot up exponentially compared to something just generating text, right? Are we even prepared for that level of operational rigor?
That is the core strategic question leaders need to grapple with right now. The implication from the sources is that the intense operational rigor of that seven-phase life cycle we detailed isn't just best practice, it's becoming absolutely mandatory, precisely because agentic AI carries this massive potential risk and reward.
Yeah.
The model isn't just suggesting a recipe anymore. The agent might be automatically ordering the ingredients, managing inventory, or even optimizing a complex supply chain based on real-time data. The stakes are much higher.
Okay. And the fourth component.
The fourth is physical AI. This is where AI gets integrated into tangible hardware systems. Think advanced robotics, autonomous vehicles, smart factories. AI moving off the screen and into the physical world. Leaders need to understand these four dynamics: descriptive, generative, agentic, physical, to anticipate change and avoid getting caught flat-footed.
Okay, so you've got these waves, these surges, all this complexity. What's the biggest strategic mistake a leadership team can make when faced with all this? The sources seem to warn against just implementing AI for AI's sake.
That is the absolute crucial strategic trap. There's immense pressure, right? FOMO, fear of missing out. Leaders see competitors launching AI features. They read about the latest amazing LLM.
Yeah, gotta do something.
Exactly.
Yeah.
And the temptation is just to grab that shiny new tech, say, the latest LLM, and desperately try to find some problem to apply it to within the company, just to show they're doing AI.
Tactical reaction, not strategy.
Precisely. It leads to scattered pilots, wasted resources, and initiatives that don't actually move the needle on core business goals. What leaders must do, according to the sources, is perform what they call a crucial inversion.
A crucial inversion, meaning
Meaning you flip the process entirely. You don't start with the technology. You start by clearly defining the tangible strategic business results you need to achieve. Are you trying to optimize logistics, cut customer service resolution time by 30%, accelerate drug discovery and R&D? Get specific, measurable.
Okay, define the result first.
Yes. Then and only then do you work backwards to figure out which specific AI technologies, maybe is a simple chatbot, maybe it's a sophisticated RG system for internal knowledge, maybe you actually need an agentic framework, are the right tools to achieve that predefined strategic target.
So the desired result dictates the necessary technology, not the other way around.
Exactly. It sounds simple, but it requires discipline to resist the tech hype.
This sounds like it requires genuine strategic foresight. You mentioned looking 2 steps ahead. How does that play out when making, say, a big resource allocation decision today?
It's absolutely vital for resource allocation.
Okay.
Let's say an organization gets completely fixated on optimizing the current Gen AI wave. Maybe they decide to pour millions into deeply fine-tuning a custom LLM for a specific narrow task. If they do that blindly, without looking ahead, they might unintentionally hamstring their ability to adopt the next wave of agentic AI when it matures in, say, 18 months. That agentic wave might actually be far more strategically important for their long-term goals.
Ah, I see. The big GenAI project today could consume the budget and the key personnel.
Exactly. The capital, the skilled engineers. They might all be tied up in that custom fine-tuning project, which might become obsolete almost immediately when a more powerful agentic platform emerges that could solve the problem more effectively.
So you have to ensure today's perfectly rational investment doesn't accidentally block tomorrow's necessary transformation. It's a real dilemma.
It's a critical resource allocation tightrope walk. You need to balance present needs with future readiness. Hashtag 2.3, the 4 core challenges to adoption. the fundament. Okay, so before a company can even think about effectively riding any of these waves, its internal foundation has got to be solid. The sources suggest success here is actually less about sheer speed and more about meticulous positioning.
Positioning over speed. Interesting.
Yeah, and we can structure that readiness, that positioning, around tackling the four biggest, most common challenges to AI adoption.
All right, let's break them down. Challenge number one, the sources highlight is orientation. This often sounds like people inside the company asking, okay, where do we even start?
Exactly, that feeling of being overwhelmed. You hear about LLMs, LangChain, vector databases, different cloud providers. The sheer number of options can cause total organizational paralysis, analysis paralysis.
So how do you break that paralysis?
Well, it loops back to that crucial inversion strategy we just talked about, that paralyzing complexity. It starts to dissolve the moment you apply a result-focused approach. If a team knows their specific mission is, say, reduce customer churn by 15% this year, suddenly that vast, confusing technology landscape narrows dramatically. You can focus only on the tools realistically capable of hitting that specific metric.
Okay, focus clarifies the options. What's challenge number two?
Challenge two is technology. Once you have some orientation, you face the hard choices. Which specific tools should we actually commit to?
Right, big decisions here.
Huge decisions, like, do we build custom models in-house, which is expensive and slow but tailored? Or do we buy off-the-shelf solutions which are faster but maybe less flexible? Which tech stack do we need? Do we need basic LLMs or more advanced agentic frameworks for the tasks we've defined?
And the big one, compatibility.
Oh yeah. How do we ensure these shiny new AI tools can actually integrate with and get data from our often decades-old legacy IT systems? That integration piece could be incredibly costly and complex, a major hidden challenge.
Okay. Challenge three moves to resources. The question becomes, what core assets do we absolutely need to make this succeed?
And as we spent so much time on in section one, the answer comes back loud and clear. Data. Model quality is utterly dependent on data quality.
Right.
This means successful AI adoption is fundamentally reliant on having your data ready.
Yeah.
And critically, having strong data governance in place.
What does data readiness mean in practice here?
We're talking about a significant organizational shift. It means ensuring all potentially relevant data is clean, properly prepared, accurately labeled, and readily available for consumption by machines, not just by human analysts looking at spreadsheets.
Who's machine readable and accessible.
Yes. If your data governance is weak, if your data is locked in silos, if it's messy, biased, or unusable, your AI initiative is likely doomed before it starts. It will fail right at the foundation. Leaders absolutely must prioritize investments in data infrastructure and governance, arguably above almost everything else.
Got it. Data is the fuel. And finally, challenge four is competency. The big question. Do we actually have the skills inside the organization to implement and then maintain this stuff?
Right. You can buy the best tech, have perfect data, but if your people can't use it effectively...
It just sits there.
Exactly. Introducing AI requires a really honest surgical skill gap analysis. And it's not just about finding more Python coders or machine learning engineers, though you might need those. The required skill sets are evolving.
Like what? What are the new skills needed?
Well, the sources specifically highlight the crucial new skill of prompt engineering.
Prompt engineering, basically knowing how to talk to the AI.
Essentially, yes. People across the organization need to understand how to communicate effectively with these models to get reliable, useful, actionable output. A brilliantly powerful model, if prompted poorly, is just an expensive, wasted resource.
Makes sense.
So leaders need to realistically assess their current capabilities against the demands of the chosen technology and the defined purpose. And then they need to invest. Either hire the skills, or more likely invest heavily in training and upskilling their existing workforce.
So tackle these four challenges: upfront, orientation, technology, resources, competency. Get your house in order first.
That's the idea. If you position yourself well by addressing these fundamentals, you're ready. You can then seize the right AI wave at the optimal moment with confidence. An unprepared company, they'll inevitably just get swamped by the complexity and the pace of change. Hashtag 2.4 implementation and iteration, the process.
Okay, let's say you've done the prep work, you've tackled those four challenges, now you're moving into the implementation phase. The sources talk about a really interesting dynamic here, this need to balance strategic patience with decisive action.
Yeah, they frame it as managing timing versus decisiveness. The pressure to innovate, to launch something, is always incredibly high in the market right now.
For sure.
But pure reactivity is dangerous. Patience, the sources argue, can actually be strategic. You might need to consciously wait for that critical moment where everything aligns your clearly defined goals, your team's necessary skills, your clean and ready data, and the maturity of the specific technology you need. That intersection point. That's your moment of optimal strategic positioning.
But waiting too long is also a risk, right? You can't just wait forever. Analysis paralysis again.
Absolutely. Waiting too long becomes its own form of paralysis, just as damaging as rushing in unprepared. So the key is, once that optimal moment does hit, when goals, skills, data, and tech are aligned, the organization must act, and act with decisiveness.
Okay, seize the moment.
Yes. Make the call. Take calculated, informed risks
I do.
based on all that careful preparation you've done across the four challenges. Hesitation at that critical juncture just squanders all the positioning work, all the resource planning. The window might close.
And once you've acted decisively, leaders need to embrace adaptability, right? Because the tech itself is changing so incredibly fast. The sources mention major shifts happening every 6 months.
Easily. Maybe even faster in some areas.
Yeah.
You simply cannot expect a detailed implementation plan drafted today to remain perfectly relevant a year from now. It's just not realistic.
So the plan is always provisional to some extent.
It has to be. It's an accepted truth in this field. No AI implementation goes perfectly according to the initial PowerPoint slides. Internal processes, team structures, workflows, they must continuously adapt to accommodate these powerful new tools and the sheer pace of innovation.
So leaders need to foster a culture where that constant adjustment, that pivoting, that iteration, it's not seen as failure. It's
Yeah.
just,
Exactly. It needs to be the normal operating state of the business in the AI era.
yeah.
Constant learning, constant refinement.
Which brings us to the idea of failure. How should organizations view failures or unexpected results in AI projects?
Not as setbacks, but as valuable data. That's the key mindset shift.
Okay.
Wrong turns in development, unexpected model drift once deployed, pilot projects that yield suboptimal results. These aren't failures to be buried. They are critical data points. They
Yeah.
tell you something important about your assumptions, your data, your process, or the technology itself.
We'll learn from them.
You have to. The key to success, long-term, is establishing really short, tight feedback cycles. Implement something small, a pilot maybe. Measure the results rigorously against your defined goals. Learn from the discrepancies from what worked and what didn't, and then immediately adapt your strategy based on that learning.
Implement, measure, learn, adapt, repeat.
That's the loop. Since these AI waves are continuous and evolving, the organization's ability to iterate quickly, learn effectively, and adapt intelligently. That becomes the single most decisive factor for sustainable strategic success in this landscape.
Okay, let's try and bring our two halves together now. We've got the deep operational rigor of the 7-phase life cycle for building one model well,
The how.
and we've got the high-level executive strategy for navigating these broader AI waves.
The when and why.
Looking at them together, it seems clear they're completely interdependent, aren't they? Like two sides of the same coin.
They absolutely are. You can't have one without the other, not if you want sustainable success. That detailed life cycle, it provides the essential technical discipline, the rigorous data cleansing, the bias testing, the constant drift monitoring, the secure deployment practices.
The foundation?
Exactly. That operational foundation is absolutely required to actually execute any of the high-level strategies effectively. I mean, you simply cannot ride the AI wave if your core models are constantly failing, leaking private data, or becoming dangerously biased 6 months after you launch them. The strategy falls apart without the operational excellence.
And conversely, that strategic foresight, that crucial inversion thinking, it dictates which models you should be building with that rigorous life cycle in the first place.
Right. It ensures your highly skilled operational teams aren't wasting precious time and resources meticulously building and optimizing a model based on, say, yesterday's Gen AI tech, right when the next strategic surge, like agentic AI, is about to make it obsolete or less relevant for your key goals. Strategy guides operations. Operations enables strategy.
Now, what's often overlooked, and the sources really emphasize this, the biggest hurdle often isn't the technology itself.
No, it's rarely just the tech. More often than not, the biggest challenge is organizational and cultural.
Resistance to change.
Resistance to change, yeah.
Yeah.
Whether it's explicitly articulated, people demanding to slow down, raising endless objections, or just a general lack of enthusiasm or buy-in, that resistance is almost always a symptom of deeper issues.
Like what? What are the underlying causes?
Usually it boils down to cultural fears, fear of job displacement, fear of the unknown, fear of losing control, or it stems from a fundamental lack of competency building across the organization. People resist what they don't understand or feel equipped to handle.
Okay, so if resistance is often a symptom of fear or skill gaps, what's the antidote? How do leaders overcome that?
It comes down to two things mainly: transparency and empowerment.
Transparency and empowerment.
Yeah. Transparency about the strategic goals, the why behind the AI initiative, and clarity about the expected business results and impacts. That's critical for reducing uncertainty and fear. People need to understand the purpose.
Makes sense. And empowerment.
That's the direct remedy for resistance based on skill gaps or feeling overwhelmed. You need aggressive, ongoing competency-building programs.
Mm.
Training, upskilling, clear support structures. You need to empower teams with the knowledge and tools they need to participate confidently.
So it's not just an IT project thrown over the wall.
Absolutely not. This kind of transformation, it isn't a solo project for the tech department. It has to be a genuine team performance, requiring alignment and collaboration across data teams, development teams, business units, and critically, executive leadership, setting the tone. Hashtag outro.
Wow. We have covered a huge amount of ground today. We went from the nitty-gritty, the technical necessity of building ethical guardrails right into phase one using our recipe generator example, all the way up to the C-suite level, the strategy for navigating those four big adoption challenges: orientation, technology, resources, and competency.
Yeah, quite the journey from micro to macro.
And just to recap a few key nuggets for you listening, we talked about the efficiency boost from using MOE architecture, the absolutely critical compliance role of that AI governance review board.
Crucial.
We defined drift and why monitoring it in the maintenance phase is non-negotiable, and we stress that crucial inversion always define the business result before you pick the AI technology.
All key takeaways.
Yeah.
And as we wrap up, maybe we can circle back to that dynamic landscape, the one that forces this constant adaptability we've discussed.
Okay.
If we accept the analysis that the next major surge really is agentic AI, these systems designed to learn and execute complex tasks pretty much on their own.
Well, that raises a really important, maybe slightly provocative question for you, the listener, to think about.
Go on.
How fundamentally does that rigid 7-phase life cycle we so carefully outlined, how does it have to change when the developer or the maintenance operator itself is increasingly an autonomous AI agent, making its own design choices, its own tuning decisions?
Whoa. When the AI starts maintaining the AI. Exactly. And maybe even more profoundly, what new forms of organizational resistance, what new cultural challenges will inevitably emerge when companies start integrating a workforce component that is constantly learning, constantly adapting, and operating autonomously?
That's the ultimate strategic challenge looking ahead. A lot to think about there. We really encourage you to keep exploring these topics, integrating these blueprints and strategic thoughts into your own work and thinking. Thanks so much for joining us for this deep dive.